13.8 billion years ago, a speck of energy burst into life. We call it the Big Bang. Space and time pushed out in all directions. Ever since, our universe has expanded. But the way it's expanding makes finding an edge a major challenge.
The universe is expanding, and expands according to a very simple law, that the farther away a galaxy is from us, the faster it appears to be receding away from us.
The furthest galaxies are moving at very high speeds. The most distant galaxy we've ever spotted, GNZ 11, seems to have moved 32 billion light-years away from us in just 13.4 billion years. That's faster than the speed of light.
We can measure the speeds with which galaxies are moving away from us. And many, many galaxies are moving away from us at speeds faster than the speed of light. This sounds like it's breaking the law, right?
There's this idea that you've all been told that relativity says nothing goes faster than the speed of light. Okay, you've been lied to.
Space itself can do what it wants. It makes the rules. It can break the rules. That rule applies to matter, not to space itself. Space can expand at whatever rate it wants.
A simple way to think of this expansion law is imagine standing on an infinite rubber sheet that stretches all the way out into the distance, and you're standing on the same place. You can mark it with a little X. Now, all the sheet expands in every direction. So if it expands by a factor of 2, another galaxy that was, say, 1 foot away from you is now 2 feet away from you as we stretch the sheet. But another galaxy was 10 feet away from you. Expand that by a factor of 2, and now it's 20 feet away from you. So in the same amount of time, one galaxy moved 1 foot, where another galaxy moved 10 feet. So the more stuff there is, the more elastic between you and another galaxy, the more it seems to expand away from you.
Expansion means our observable universe stretches for a colossal 46 billion light-years in all directions, 92 billion light-years across, and getting bigger by the second.
This number is so incomprehensibly large that it's difficult to wrap your brain around. There are trillions of galaxies within this volume. It's staggering. It's so much larger than anything we're familiar with.
If we were to travel to the edge of the observable universe, we would enter even more unfamiliar territory. Imagine we're in an ultra-fast spaceship. We leave the solar system, then the Milky Way. As we travel deeper into intergalactic space, things start to get really weird. For every million light years we go from the Milky Way, the galaxies move away from us at around 13 miles per second faster. We have to accelerate just to keep up. But the galaxies keep on moving, always beyond our reach.
Imagine you're a sprinter on a racetrack. If you're running towards the finish line, it may take you a few seconds to cross it. But now imagine that that finish line is moving away from you. If it's moving away from you at the same speed you're running, you'll never reach it. And if it's moving faster than the runner, then even faster runners won't reach it. And that's sort of what we're seeing here with the universe.
Beyond a certain distance, galaxies are racing away from us faster than the speed of light. It's a line called the cosmic event horizon. And 97% of galaxies we see in the observable universe are beyond this line and unreachable, including GNZ 11.
They're sort of teasing us to say, look at me, what a nice piece of real estate. But we know even if we started going there now, we could never reach them.
Anything that has crossed the cosmic event horizon is out of our reach forever. But that's not the full picture, because the expansion rate of the universe is changing.
A little over 20 years ago, astronomers discovered that the current rate of the universe's expansion is accelerating. It's speeding up.
Astronomers suspect a mysterious force is at work. Dark energy.
Dark energy is what we think is pushing the universe apart, causing this accelerating expansion. And the origin and true physical nature of dark energy is a big mystery.
Thanks to dark energy, more and more galaxies are crossing the cosmic event horizon and leaving the observable universe. These galaxies are lost to us forever.
There are galaxies that we can see today that in a few million years, say, we won't be able to see because the edge of the observable universe has basically moved in closer than that galaxy. That's going to happen all the time. And in 1 trillion years or something like that, all these galaxies that we see in our sky will be completely invisible because they'll be beyond the edge of the universe.
So eventually, every last galaxy will be so far away from us that light cannot reach us through that expanding space. It's almost as if you're driving through a dark desert in your car, and the very, very last town that ever exists has gone over the horizon, and there'll never be any light again.
We can see less and less of the universe as we go into the future. What a strange thought. So that means we should build all the telescopes we can now.
There's a limit to the universe we can see, even with the most advanced telescopes. But what lies beyond is one of the biggest mysteries in astronomy. The greater universe could be stranger than our wildest imagination.
When you stand on the beach and you look at the horizon and you kind of think, oh, what beautiful lands are there beyond the horizon, things I've never imagined before.
It's so natural, it's so human to ask what lies beyond that. What is the true extent of the universe?
The observable universe contains trillions of galaxies. It's about 92 billion light years across. But astronomers believe this isn't the full extent of the universe.
What we don't know is how much of the universe is our observable universe. It could be a tiny microscopic speck of this much more vast universe. We just don't know.
We have no idea how much stuff there is outside the observable universe, but because, by definition, it's outside the observable universe, we really don't know right now.
So what is out there? One theory says that space outside the observable universe is pretty much the same as our own cosmic neighborhood.
It's just more universe. It's just like here. It's just far enough away that we can't see it. So it's not like there's bizarre places where time runs backwards or aliens have two heads. Well, yeah, maybe.
But further out, in the deepest parts of the greater universe, all bets are off.
We expect that as you go sort of twice or 3 times beyond the observable universe, it's probably very similar to the universe we inhabit. But if you go 1,000 times or 1,000,000 times farther, who knows what you might see?
It might be very, very different if we go far enough away.